Hey guys, this is Unit 1 again, Lesson 1.5. So the essential question to remember is how can you tell two quantities which appear to be different are the same? And for 1.5, our aim is going to be what are the deeper relationships between the sides of a right triangle? So let's start off by talking about what a Pythagorean triple is. So let's copy this down. A Pythagorean triple is a set of positive integers, a, b, c, that fit the rule. And you've definitely seen this rule before. A squared plus b squared equals c squared. Here's a common mistake people often make is when we talk about a, b, and c and we talk about them in terms of a right triangle, a and B don't actually matter where you put them, they just have to be on the legs, but C must be the larger side, or the longest side, I should say, not the larger, but the largest, or longest. Largest side. A and B could be either of these legs, doesn't matter. So oftentimes we don't realize that this number C has to be the biggest number. So when you do have three numbers representing the three sides of a triangle, C will always be the biggest number. Okay? So let's look at an example of a Pythagorean triple. Again, the Pythagorean triple is just any three numbers that are integers that create a right triangle. So what's really important here is that they have to be integers. If you don't remember what the set of integers is, it's any positive or negative whole number. Positive or negative whole number. So -3, -2, -1, 0 is not an integer, 1, 2, 3, 4. Okay, so that means no radicals, no decimals, no fractions. It has to be a whole number, positive or negative, in order to be an integer. So let's look at an example. Example 1 says, show that 12, 35, 37 is a Pythagorean triple. Okay, well, we can use a squared plus b squared equals c squared, and if it fits this rule, then it's a Pythagorean triple. One thing I want to think about, like we said, is that this number over here has to be the largest number, so that means 37 is going to go over there. So this is 37 squared. For A and B, it doesn't matter which one I write first or second, or which one I call A and which one I call B. So 12 squared plus 35 squared. So we are seeing if it's a Pythagorean triple, we're seeing if both those sides are equal to each other. So let's start out by squaring 12. When we square 12, we get 144. Then we're going to square 35. When we do that, we get 1,225. And when we square 37, we get 1,369. So notice I'm putting the question mark over the equal sign because we don't know if it's true or not yet. So now we're going to add the 144 and the 1,225, and we get 1369, which is equal to 1369, proving that this is a Pythagorean triple. 12, 35, and 37 do create a Pythagorean triple. Okay, let's go on to another example. Before we do that, though, we're going to learn about a rule for finding Pythagorean triples. So, you can find a Pythagorean triple just by picking any two numbers and using this formula. I'm going to call it a formula today, but tomorrow you're going to learn a different word for it. Okay, so quantity x squared plus y squared, all squared, equals quantity x squared minus y squared, all squared, plus 2xy, all squared. So if we use this formula, we can find any Pythagorean triple by just picking a number for x and picking a number for y. So let's test it out. So example 2 says, find the Pythagorean triple by making x equal 2 and y equals 1. So we're going to use this formula. We're going to create a Pythagorean triple by, again, making x equal 2 and y equals 1. So When we say find a Pythagorean triple, that means find those values of A, B, and C. So we're going to do that. So when you look at this formula in red, what you should think is this side is going to create our C value, and then here and here are going to create our A and B value. So I'll just say this is our B value, this is our A value. Okay, so let's start substituting some stuff in. So I'm going to rewrite this formula down here so we can see clearly the substitution. Okay, and I am going to substitute 2 in for x, 1 in for y. So 2 squared plus 1 squared, all squared, equals, and then I got 2 squared minus 1 squared, plus 2 times 2 times 1, all squared. Okay, I'm going to keep going. So now I'm going to simplify everything inside those parentheses first. So 2 squared is 4, 1 squared is 1. 2 squared is 4, 1 squared is 1. 2 times 1 is 4. Now I'll take care of the exponents. I'm following my order of operations. Excuse me, common mistake that comes up, people don't follow the order of operations and try to apply this exponent first, or try to add these terms. We need to make sure we follow order of operations. I'll write it on the side here. Okay, parentheses, exponents, multiplication, division can be done either one first, addition and subtraction. Again, same thing, either one. Okay, so I'm going to continue. 5 squared. Whoops, okay, here we go. 5 squared equals 3 squared plus 4 squared. And now I have 5 squared, which is 25, equals 9 plus 16. 9 plus 16 is 25. There we go. So we just showed that both sides are equal, which is important. It's an important part of this, using this formula. And again, we'll learn that word for it tomorrow. So what are our 3 terms, A, B, and C, that create this Pythagorean triple? What are the 3 integers that create this Pythagorean triple? Hopefully you took a second to think. Those 3 integers can be seen right here. Imagine this was C, B, and A, or again, it doesn't matter where you put the B or the A. So 3, 4, 5 is a Pythagorean triple. We just created that by assigning x a value and y a value and using this formula here. That formula will always give us a Pythagorean triple. Okay guys, that's it for now, and we'll see you tomorrow.